Now that we've done a bunch of questions on growth and decay, I want to use what we learned in order to be able to interpret other questions. What do I mean by this? Well, think about this. Remember that wonderful question we had on bacteria that said the bacterial growth, the number of bacteria that we have started with 5 bacteria and then it doubled every hour. That gave us a beautiful formula that looked exactly like this. And what did this mean? Well, it meant that this 5 here up front was our initial amount, right? That was our initial amount. Now, what's this mean? That was meaning that it was doubling. Remember this? It was doubling, which means that this is our growth factor. But can it also be something else? Yeah, as a matter of fact, it could be our growth or our decay factor. Remember that question then on isotopes and how the radioactive isotopes decay. So this is our growth or decay factor right here. Now it makes sense. So now if we look at this particular question coming up and we look at a formula like this, we can now interpret it. Read the question. It says the growth of the internet can be measured by the number of computers offering information. We call them hosts. Okay? The number of hosts, this is important, in millions for T years. Well, gee, look at that, T years. But it says after 1995 is modeled by this function. Okay, wait a second. Let's interpret this now. Let's tell me what's going on with this particular exponential function. Well, n then determines the number of hosts we have, right? 7.4, what does that entail? That's our initial amount. What do you mean, 7.4 hosts? No, it's in millions. So this is 7.4 million hosts. And if you think about it, 7.4 million hosts is not that much. Well, think about it. This is 1995. That was a long time ago. The internet wasn't very big. It's nowhere near what it is today. Aha, interesting. Okay, let's keep on going with this then. So we started with 7.4 million hosts in 1995. Now, what's this 1.59 here mean? Think about it, to the power of t. Think about it. 1.59 means 159%. Does this mean that this thing's growing by 159%? No, 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 no. It's growing by 59% per year. That's what it's growing by, according to this model. Interesting, interesting. Now, what else does this mean? What is this t? Well, t is not 1995. You put 1995 in there, this thing is going to blow up. You have to remember that t starts at 1995, which means, 95, which means that's not 1995, that's starting, which means t is 0. 0 represents 1995. Nice. Now, this particular question says, graph me the function then. Now that we know all that we know about this, right, it asks you to graph the function. And it wants you to graph this function from 0 to 25 years. So from 1995, which is now our 0, plus 25 more years, okay, which is what they want you to show. This is your domain. They're fixing your domain here. So let's actually put this into our calculator. Okay, 7.4, here we go, 7.4, right? That's our initial amount, 1.59 to the power of t. So bracket 1.59, bracket to the power of t. Well, we don't have t, so we have x. Now, what does this mean now in terms of the rest of this problem? How are we going to put this in there? That's your domain. Remember, that t is now x. So you're going to go from 0 to 25. Okay, so let's go into our window. We're going to go from 0 minimum to a maximum of equaling 25. And we're going to graph it. And it looks an awful lot like, oh my God, it looks like this. It looks terrible. Well, why? Because you're starting at 7.4. You're starting way over here, and it's an exponential J curve that's going to go crazy like this. So obviously, your Y window settings should be a heck of a lot more. Let's put our Y window settings up to, I don't know, let's put it up to 10,000. Why 10,000? 10,000 million is just basically 10 billion. Do we have 10 billion hosts out there now? Oh, we got a lot more than that, folks. We got a lot more than that. Consider how much for example, a tweet from some sort of celebrity suddenly goes viral. Shouldn't be called goes viral, it should be called goes exponential. Watch. Boom. There it is. See how it works? It's amazingly interesting, isn't it? Let's keep on going then. So it asks you here, now in this particular question, estimate the number of hosts in 2015. Well, think about it. We're going from 1995 all the way to 2015, right? Isn't that 20 years? Well, yeah, that's 20 years. But so what? Well, so this, your T. This starts at T0. That must mean that this is T20. 2015 is, in fact, T20. So if you're going to do this question properly, you're going to go n equals to 7.4, 1.59 to the power of 20. Well, let's do that right now. 7.4, 1.59 to the power of 20. Okay, I'm going to do it right here. 7.4 bracket 1.59 to the power of 20. Okay, close the bracket. There it is. Let's go. Figure it out. Enter. That gives me 917.6. Let's go 78,918. 78,918 million hosts. Wow, that's amazing. Because remember, a billion is 1,000 millions. So this is 78 billion hosts now. Almost 79 billion hosts. Wow, that's crazy. But here's something that's interesting. Let's go back and let's actually find out when they actually reached a billion hosts. This should be interesting. Well, again, you got to use your graphing calculator for this, because a billion hosts, you got to remember, is 1,000 million, right? That's a billion, equals to 7.4, 1.59 to the power of t. Now, the fact is that you've got this already in your calculator. This should make it really, really easy. Just go back to your calculator now here. Go to y equals 2. Go down to y2 and put down 1,000. There it is. There's 1,000 million, which is a billion. Graph it. Boom. Find the intersect. Second calc. Find me the intersect. 5. Enter, enter, enter. And look what you got. 10.57. So when did this happen? This happened 10.57 years. So t equals to 10.57 years. So it looks like about 10.6 years from where you started. Okay, so 1995 plus 10.6 years works out to be 2000, right? And 5, right? And a half, and 0.6. So somewhere in the summertime of 2005, they hit a billion hosts. See how understanding the equation now can really help you in solving some of these problems.